Hi everyone. Today we will give or revise some information about the probability that we have explained before in grade 9. So what about relative frequency and the probability? What is the relation between these two concepts? Normally, we should know that the relative frequency of an event can be used to predict. It is an indication about what will occur in the future. Okay, so normally, if we have an experiment done on a space or on a population, given population like here, normally we have run on an experiment on different 400 car drivers, okay, on 400 car drivers. So normally to know the origin of their cars, okay? So normally we have a population, the cars, the 400 cars or the 400 car drivers. Okay, so normally we have frequency, the origin of cars, Australia, Japan, Korea, Germany, and other countries. Okay, so normally we have this table and these numbers. How to find the relative frequency? The relative frequency by definition is the frequency over the total. Over the total. Okay, so normally Australia, the relative frequency for Australia, it is the frequency 185 divided by 400. It is equal to this decimal number. And how to find the percentage? But in general, the percentage is the frequency or the relative frequency multiplied by 100. We have a mistake here, mistake with the rule, okay? Or it is equal to frequency over total by 100, okay? Because you know that the frequency over the total give us the relative frequency, and then after multiplying it by 100, we will obtain the percentage. Okay, so it is easy to know all or to find all these values, relative frequencies and percentage of each country. Okay, they in part B they ask us to using this data estimate the probability that another driver chosen at random will own a car manufactured in Australia. The probability is the relative frequency manufactured in Australia. It is like they ask us about finding the relative frequency for Australia. So it is 0.4625. How about estimating the probability that the driver's car has been manufactured in Japan? Normally the probability, so they ask us about the relative frequency, so it is 0.2325. Okay, moving on to the next exercise, a poker die has faces. We have 6 faces for a poker die, A, K, Q, G, and 10 and 9 as numbers, and is rolled once. Okay? We are interested on the face, occurred face, okay? So determine the probability of getting a K. AK, 1K, so normally it is 1 over 6. Okay, it is 1 over 6 because we know when these faces are different. So normally the probability of to have one of these faces is equally likely for the others. Okay, so all these one, the probability of each one is 1 over 6. A number, we have two numbers, so 10 or 9. So normally it is, we have two numbers from 6, so 2 over 6, so 1 over 3. Also, when they ask us to find the probability of getting an A or a K, or, so it is a plus, so that it is the probability of having an A, or plus the probability to for having of getting a K. So we know that the probability of getting NA is 1 over 6 and the AK 1 over 6. So in total, we have a 1 over 3. We should know that the greater the number of trials, more reliable or pertinent the probability estimation will be. Okay. Normally, it is very easy also to to discuss this experiment. Like a game is played with a normal six-sided die. Normal six-sided die. Normally, with the die has six faces. All the faces has probability of occurring equally likely probability of occurring 1 over 6, and each we have the numbers from 1 to 6 as their faces. Comment on that statement. I need a 6 to start a game. Okay, I need a 6 to start a game. Therefore, the probability that I will start on my first row is 1 over 6. Yes, of course, because we know that the normal six-sided die, we have all the sides are 1, 2, 3, and 4, and 5, and 6. And each face, the probability 1 over 6, with the probability 1 over 6. So to start the game, we need the 6. So the probability that I will start on my first row is 1 over 6, because we need the face with number 6. Okay. What about the next one? Christina rolled a normal six-sided die 6 times. 6 times. The same die 6 times. She did not throw a 6. Okay. Christina concluded that the probability of obtaining a 6 was 0. Why is she wrong? Yes, she's wrong because she normally, first of all, she could obtain in each trial, she could obtain 6 with the probability 1 over 6. Okay, so how many 6s would be expected in 6 throws of die? She can expect at maximum 6 6s. She might have 6 6s. She might have 6 6s, or less, or less. Okay. Okay. A hat contains 5 red, 7 white, and 8 blue tickets. A ticket is selected at random from the hat. Determine the probability that the ticket is red. Okay. We should know that here, in this case, the red, the white, and the blue aren't likely equaling outcomes, because we have a 5 red, we have a 7 white, and we have 8 blue tickets in the same hat. So normally to have a red 5 over the total, 5 plus 7 equal to 12, and 20 over 20. To have a blue, it is 8. The chance is 8 over 20. The probability to have a white ticket, which I'm selecting white ticket, normally it is 7 over 20. Not blue, not blue. So 5 plus 7 can be red or white. So 5 plus 7 over 20. 5 plus 7 over 20, 30, equal to 12. 12 over 20, and we could put the irreducible fraction equivalent one here. So normally we can divide it by 4 to obtain a 3, and we can divide by 4 in the denominator to obtain a 5. Okay. We should know that each experiment and the probability or the result could be represented in different form, like Venn diagram or table, two-way table. Okay, we have a lot of way to represent the distribution. Okay, the spread of results. So normally here we have the Venn diagram. The Venn diagram always represent how the results are diffused. Okay, basing on different qualities. Here we are interested in the black hair and the brown eyes of students in a class. So normally here we can remark clearly that this region is for the student who have black hair and brown eyes, intersection between them. We have a 10 with a black hair without brown eyes, and we have a 7 student with a brown eyes without a black hair, and we have 9 students haven't no black hair, neither black hair nor brown eyes. So black hair and intersection, so 4/30. We always divide by the total number of students, which is equal to 9 plus 10 plus 4 plus 7. We have a 30 students for this experiment, in this experiment. Okay, black hair or, so we add or a brown eyes or both, so we can add their intersections. Black hair or brown eyes or both, neither black hair nor brown eyes, neither black hair nor brown eyes, so it is equal to 9. Okay, 9 from 30. Black hair but not the brown eyes, black hair but not the brown eyes, so normally it is 10/30. This way of representing results from a given experiment. It is known as the two-way table. We are here interested with the study of history and the study of art or not. Okay. So in the row, we are interested with the quality, with the criteria of studying art. In the column with studying history or not. Okay, so we should in this the type of representation, we should find the number in the appropriate row and column and calculate the probability based on the obtaining or on the convenient one. So find the probability that a student chosen at random from this class will study history or art or both. History, so we have to add this row, all this row. So it could be history with art, history without art, okay? Or both, or art. So normally we are interested in these two numbers, and we are interested in these numbers. So normally we want to add also 8 plus 6, but we already added 8. So normally we add it once. So it is 8 plus 12 plus this column, we add only the 6 to obtain 26/33. It is very important that the probability remains a value between 0 and 1. So normally it can exceed the unit 1. Okay? In part B, history or art, but not both. History or art. So history, study history. So normally it is like 20 to studying or art, but not both. Okay, so it could study history and not art. It is 12 or plus. It can be art without history. So it is 6. Okay, so 12 plus 6, 18/33, and so on. It is easy. We should know if we have multi-stage experiment with independent events. So we can use the product rule. So we should know if A and B are 2 independent events. What we mean by 2 independent events? So the result of the first event doesn't influence the result of the second event or experiment. So normally in this way, probability of A and B equal to the probability of A by the probability times the probability of B. Like here, we have a bag contains 4 red balls and 3 blue balls and 2 white balls, and spinner has the number 1 to 5 on its probability. The spinner is spun without any relation, any connection with the chosen of a ball from the bag. So normally, these two events, spinning on the spinner and choosing a random ball from the bag, are two independent events. So we can use the the product rule. Find the probability of getting a 5 and a blue ball. 5, we have 5 from 5 numbers. So it is 1 over 5 because all the numbers in this spinner are equally likely to happen. Okay. And for having a blue ball, so there's a blue 3 from 7 and from 9. So 3 from 9. In total, we have as a probability for this event 1 over 15, and so on. So also the remaining details are very trivial. In the next exercise, we have 3 coins are tossed. What is the probability of getting 3 tails, 2 heads, 2 heads and a tail in that order, at least 1 tail? Normally, when we read all the questions, all the parts, we should know that we are interested in order. So we have, like, if we toss 3 coins, like we had first coin, the result of second coin, and the result of third coin. So we are interested in order. So normally we are interested to put the results in a tree diagram. So tree diagram, the first coin we can obtain head or tail. The second one, if we obtain a head in the first one, we can obtain head and tail also, and so on. So normally that's we could or it is easy to find the sample space. Corresponding sample space it is like HHH, HHT in order. Okay, HHH, we have a first one, the head and a head and a head, the third one, and so on. So normally, if we want to, the sample space, the number of possible outcomes are like A8, N8, and the possible outcomes for the first event, 3 tails, is 1 because once occur once. The 3 heads occur, 3 tails occur once. Sorry, the 3 tails occur once from the possible outcomes equal to 8, 1 over 8. B, 2 heads and a tail, 2 heads and a tail in that order, 1, 2, 3. Okay, we have a 1 from 8. We don't have another 2 heads and tail in that order, in any order. So the importance is to have 2 head, the same 2 head and 1 tail in the same event, without caring about the order. So normally we have a 1, we have a 2, we have a 3. Okay, we have a 3 over 8. At least 1 tail. When we say at least 1 tail, 1 tail, 2 tail, or 3 tails. Okay, 1 tail, 1, 2, 3, 4, 5, 6, and 7 from 8. So it is easy to organize, to find an organized method to combine the outcomes of each simple event. Here we used the tree diagram. And you should know that we used to calculate the probability, we use this rule, number of favorable outcomes over the number of possible outcomes. We should know that the sample space of the possible outcomes can differ or can change from an experiment or in sampling with replacement or without replacement. You should know if for example, if we are playing, or if we involve samples in our experiments. So if the first ball is replaced, then the number of outcomes for the second stage, we can also, we are in a multi-stage event. We should know that. Okay, it's the same as for the first stage event, but without replacement. Normally, the number of possible outcomes, or the number of outcomes for the second stage event, is 1 less than the first stage event. Like here, we have a box contains 8 reds, 5 white, 3 black balls. In total, we have 8 plus 5, 13, and 16 balls in total. Two balls are selected at random. The first ball is replaced before the second one is replaced. So normally when it is replaced, so normally we are talking in the second stage, we are talking we are using the same number of balls that we have used before. Okay, so normally 16, and the second stage is we have a 16 balls also. So normally find the probability of selecting 2 red balls. So normally it is the red ball, first one. In the second stage we want a red ball, and we have 8 red balls in total. So 8 over 16 times 8 from 16, because we have an end. 2 white balls. We have the probability of selecting white in the first stage is 5 from 16, because we have a 5 white balls in the first stage. In the second stage, okay, because we replaced the white one that we have chosen. So normally we have also again 5 white balls. So normally the probability again is 5 over 16. A black and a white ball in order. So in any order, so we can have a white or a black and a black, or a black and white. So we have 2 different results for the same probability, because we have a here for the white we have a 5 over 16, and for the black we have a 3 over 16. So we multiply this probability by 2, or we can say 3 over 16 by 5 over 16 plus 5 over 16 times 3 over 16 to obtain 15 over 1, 28. Okay, at least 1 white ball. So at least 1 white ball. So we have a white ball or 2 white balls. Okay, so normally if we have a white ball at any order, so we have already used it here. And but we should know if in the first stage we obtain white ball, so in the second stage we want a ball which is not white. Not white, could be red or black, so it could be one of these in total. 8 plus 3, it is 11 from 16. Okay, and we multiply it by 2 because we have any order. And 2 white balls. So normally 2 white balls we have already calculated. What is the difference between with replacement, without replacement? Without replacement, if we selected in the at the first stage, we selected the red. So normally we have in the first stage we have 8 reds, but we selected a red. Okay, so to start we start the second stage with 7 red from 15 balls, because we selected a 1 ball before. Okay, this is the difference between with replacement and without replacement. Like here, we selected white in the first stage. So normally the probability in the first stage is 5 from 16, because we have a 5 white balls from 16 balls. But in the second stage, we start to select. We have already only 5 white, because we the white that we have selected wasn't replaced. Okay, so normally we have a 4 white from 15 balls only. Okay, and so on. So normally these are the main idea of the probability and the essential important information that we should review from the grade 9. Thank you for listening. Bye bye.